Okay, so the last part on trig identities is going to look at 3 more identities to the ones we already have. So we've already got the ones where you flip. Just kind of a review of those. If you flip sine, which trig function do you get?
Cosecant.
You get cosecant. And if you flip cosine, you get secant.
And then if you flip tangent, you get cotangent.
And if you flip tangent, you get cotangent. Okay, so that's one group that we've already learned. What if you take sine and divide by cosine?
Cosecant. No, wait, that's secant. Cotangent. No, tangent, sorry.
That's tangent. And what if you take
That one's cotangent.
cosine over sine? That one is cotangent. So that's pretty much the ones we've done so far. Okay. Let's pick a number. Okay, any number. 77. Okay. So I'm going to take the sine of 77, and I'm going to square it, and I'm going to add the cosine of 77, and I'm going to square it. I'm going to hit enter. I get 1. Let's pick one other number besides
108.
108. So I'm going to take the sine of 108. I'm going to square it. I'm going to take the cosine of 108. And I'm going to square it. Not log. And I get 1 again. So it doesn't matter what number you fill in. If you take the sine squared plus the cosine squared, you will always get 1.
What is it called? Pythagorean identity?
Yeah, this is called the Pythagorean identity because it kind of looks like Pythagorean theorem where you have something squared and something squared equals something. With Pythagorean theorem, it's a squared plus b squared. This is sine squared plus cosine squared. Right? And there's 3 different versions of the Pythagorean identity. This one has sine and cosine. The next version has cotangent and cosecant. And the third version is going to have the 2 trig functions we haven't used yet. I've used 4. What are the other 2 I haven't used? I used cosine right there.
Cotant, no.
Cosecant.
Haven't used secant and tan. So those are all called Pythagorean identities. And they all look kind of similar to the first one. They all have 2 trig functions in them. They're all squared, and they have a number 1 in the formula somewhere. Now, let's take sine squared plus cosine squared. Sine squared plus cosine squared equals 1. If I wanted to move cosine squared over to the right side, how would you move it over?
Subtract.
Yep, you could subtract it. If you did that, what would it leave you with on the left?
Sine equals 1 minus cosine squared. Sine squared.
Sine squared equals what?
1 minus cosine squared.
Yep. That's not a different identity. That's just the first one with something moved to the other side. So you can rearrange these any way you want. You could bring the cosine over to the right. You could leave the cosine where it is and bring the sine over to the right. Okay, and same with these other ones. You could take this cotangent squared, subtract it, put that on the right. So when we use Pythagorean identities, sometimes we have to look for one of the identities that we know, but rearranged a little bit. Okay, so they can be rearranged. Any question on how that is the same as that? It's the same idea like if you use this formula, distance equals rate times time. Well, you could say distance divided by rate equals time. That's the same formula. You just moved something to the other side. All right. Any questions on these three? Those are the new ones today. And the kind of problems we're going to be doing are just like what was in the homework. So they're going to be verify kind of problems. So verify means they're going to give you both sides. Okay? They'll give you a left-hand side, and they'll give you a right-hand side. We're always going to start with the side that's more complicated and try to simplify it until we get it to be the right-hand side. Just like the homework. Every problem in the homework was verify. So nice thing about verify is you already know the answer. Your goal is just to figure out how to get it.
Is the homework going to be another worksheet?
I'm not sure yet. I have a worksheet and I have the book, but I'm trying to decide which one. We'll see.
I prefer worksheets.
Yeah, mine always goes for worksheet.
Well, we'll see what kind of problems we get into, because one of them is easier than the other.
Which one's easier?
Okay, great.
Maybe the book.
But worksheets are so much better because I don't know what
We'll take the hard one.
honestly.
Then you don't accidentally get the wrong problem.
All right, so let's try this one. So this is a verify. Which side there is more complicated? The left side of the equal sign or the right?
Left.
Yeah, the left. The right just has a single trig function, sine squared. Okay. Whenever I see something with a trig function squared, then I start to think that maybe it has something to do with one of these formulas, because these are the trig functions squared. All right. So what's the first thing that I could do on the left-hand side? And this is a step we learned on Monday.
Make the CSC into a sine over sine.
Okay, so let's make
We'll put sine over 1.
put sine over 1. And what's cosecant?
Oh, I forget. Yeah, cosine over sine?
It's gonna be 1 over sine.
Cosine over sine is
One over
cotangent.
sine.
Base 1 over sine.
1 over sine. So all we did was change everything to sines and cosines.
then
That's
you
already a
cancel.
cosine, so just leave that. Do not change cosine squared to anything. Now that's multiplication, so what happens there?
We cancel the sine.
Cancel.
The sines cancel out.
And then you get 1 minus cosine squared.
We get 1 minus cosine squared. Now we just did that. We have to look up what is 1 minus cosine squared. We did it right there.
The first one?
Yeah.
Sine.
1 minus cosine squared equals sine squared. So we can change what we just wrote down, this, to that, because they're the same thing. Any question why 1 minus cosine squared equals sine squared? Comes from this formula right here. Just moving cosine squared to the right side.
I had a quick question. What unit is this? Like what number?
3.3 part 2. All right, so 1 minus cosine squared turns into sine squared. And what was it we were supposed to get on the right-hand side?
Sine squared.
Sine squared. Okay. So we turn the left-hand side into the right-hand side. Okay, the difference with this one is you needed a formula you didn't know on Monday. That's sine squared plus cosine squared equals 1. Okay, any question on the first one? All right. Let's try this one. Yes?
Case method.
Yeah. So this one says sine times cotangent plus tangent somehow is just going to turn into secant. If the problem says verify, then it is doable. Okay, I'm not giving you like verify if possible. It's not impossible. It is possible. Okay. What property would we use first on the left?
Distribute.
Yeah. So we're going to distribute that out. And what is it that you're distributing?
Sine.
Sine. If we want, we could change cotangent at the same time, or we can just come back. We can do that after. So I'll just leave it for now. So sine times cotangent, and what's going to come after that?
Sine times tan.
Sine times tangent. Okay, now let's change everything to fractions. Sine I already did. How about cotangent?
No. Cosine over sine.
Cosine over sine. Any question why we changed it to that?
That's what we learned on Monday.
So we learned that Monday. Okay, we're trying to change to sines and cosines. How about sine? It's already sine,
Just put a 1 on
but
it.
you just put a 1 under it. And what about tangent?
Sine over cosine.
Sine over cosine. Now, these are two separate pieces, right? This is one piece. Then you got a plus sign, and that breaks it into a different piece. So don't try to cancel cosine in the bottom here with cosine in the top over there. Those are separate. Okay. If there's anything in the box that you can cancel, that's okay.
Sine.
Yep, you can cancel that sign and that sign. Anything over here?
No.
No. Okay. So what does that leave me with in the
Cosine
first
over
box?
1 plus sine squared over cosine.
Sine over 1. Yep. Plus sine squared over cosine. Okay. So now do we have what they told us we should get?
No.
No.
But the
Then
cosine.
there's got to be something more we can do. Is there anything else that cancels right there?
No.
No. That's a plus sign. You can't cancel across a plus or a minus, only if it's multiplication. So right now we've got two fractions. What's the denominator of the first one? 1. And how about the second one?
Cosine.
Cosine. Can we add them together the way they are?
No.
No.
What do you need to add fractions?
Like term.
Like denominator.
Yeah, you need the common denominator. Yep. So we got to find a common denominator, and that's something we did on Monday too.
Would you multiply it by cosine?
Yep. This one, the common denominator is always the product of the two. So common denominator is 1 times cosine or cosine. This already has a cosine. This one does not.
So cosine squared.
So multiply by cosine over cosine. And now, what's cosine times cosine?
Cosine squared.
Cosine squared.
Cosine squared. And the denominator is cosine. Over here, we didn't do anything. We just copy it down. But since they have the same denominator, now you can put them together. Right? So we're going to write it as one big denominator now, cosine. And what's going to go in the top?
Cosine
Cosine
squared plus
squared.
sine squared.
Cosine squared plus sine squared. And that is something special. What did we say earlier that cosine squared plus sine squared is? 1. I wrote it as sine squared plus cosine squared, but that's the same thing. All of this in the top
Equals 1.
equals 1. So now you have that. Is that what we're supposed to get on the right-hand side?
No.
Not quite. What trig function do you get if you flip the cosines?
Secant.
Secant. And now, that's what we were supposed to get.
Wait, how can you make it equal to secant?
Because if you take the cosine and you flip it, it turns into secant.
Are you allowed to split it?
Yeah, that's one of the formulas right here.
Oh, okay.
If you take the cosine and flip it, you get the secant. Okay, so that one had a few things in it. First, we had to distribute. Then we changed to sines and cosines, found a common denominator, and then used one of the new identities I showed you today. So that one had a lot of steps. You could have one like that. That's probably about as long as they would get them. Any question on that one? All right, let's try, I don't know if I want to do that. Let's try this one. Okay, which side looks more complicated, the left or the right?
The left.
Yeah, so then that's the side we're going to work with. When you have two sets of parentheses like that, what property do you have to use?
Multiplication.
Yeah, you have to multiply. And it's multiplying with a distributive property twice. So you start with that.
How do you guys do that?
Because anytime you have something, it's just like having this. Something like that.
So you don't just do what's in the parentheses first, and then, or
Well, they're not like terms, so there's nothing you can do in the
I see now.
parentheses. Yeah. If you had something like 4 plus 2, then yes, you could do what's in the parentheses first. If you had 4 plus 2, but we don't have like terms. So first thing we do is multiply the first terms. What's cosecant times cosecant?
Cosecant squared.
So we got cosecant squared, and now that we have cosecant squared, we should be thinking probably about this identity somewhere. Okay, that's the only one we have that has cosecant squared in it. So that's probably going to come up. Okay, so we got cosecant squared. What's the next thing we multiply?
1.
Negative 1 by 1.
Now do you do cosecant by 1?
Yeah, we do cosecant times 1, which is
Plus cosecant.
just cosecant. So it's cosecant times 1. What's the next thing we do?
Negative 1.
Negative 1 times cosecant
So minus cosecant.
minus cosecant. And the last thing,
Negative 1 by 1.
negative 1 times 1, which is
negative 1.
negative 1. Okay, anything that's going to happen on the left there?
Yeah, cosecant and negative cosecant every now.
Right, we have a plus cosecant, and then we have a minus cosecant. Okay, those are going to cancel out. So what do you have on the left-hand side now?
Cosecant
minus
Cosecant squared minus 1. Now let's go back at our formula and look that up. Cosecant squared minus 1. Okay, well, it doesn't look exactly like that. But what could I do to somehow get cosecant squared minus 1 in that formula?
Minus 1.
Yep, minus 1 on each side. Now you have that. Cosecant squared minus 1 is equal to what?
Cosecant squared minus.
cotangent squared.
It's equal to cotangent squared. So now where we wrote this, you can change it into that. So let's change that and then see if that's what they wanted for the answer. So this is cotangent squared. And what did they say we were supposed to get?
Cotangent squared.
Cotangent squared. So we got the right answer. Any question on that one? Yes.
Are we gonna have any like open response on the test?
Well, these are more like a short answer kind of thing.
It's like you just say within the box.
So we type in all this?
So you would either be typing some of that in and then I check how you did it, or if I gave you a multiple choice, I would give you probably not just one thing it's equal to, but I might say it's equal to one of the following, and then you have to pick which one is right.
Okay.
So if it's a multiple choice, I'd give you this as one of the answers, but then I'd throw in like 3 other ones. Yeah. Let's try. All right. So now let's look at this. Let's go back. Okay, let's look at that top one. So 1 over sine is cosecant. Everyone agrees with that? If you flip the sign, you get the cosecant? Okay. Well, let's look at this. If you flip sine, you get cosecant. If you flip sine squared, you're going to get something similar, but it's just a little bit different. You want to have a guess what would be here? It's kind of like what you had up above it.
Cosecant squared?
It's going to be cosecant squared. Yeah. Now, if you flip cosine, which trig function do you get?
Secant.
You get secant.
So if it was 1 over cosine squared, it would be secant squared.
So if you flip that, you get that. If you flip that, you get that. Yeah. So those formulas I showed you on Monday, they also work for higher powers. And you can go higher, but we don't go any higher than 2. If you flip sine cubed, you would get cosecant cubed. All right, how about if you took the cosecant and flip that? That's going back to Monday. What do you get if you flip cosecant?
Sine.
You get sine. Yep.
So if it was squared, it would be sine squared.
So if you flipped cosecant squared, yeah, what would you get?
Sine squared.
Sine squared. Yep. There's another one. Do this one. If you flip secant, what trig function do you get?
Cosine.
You get the cosine. So if you flip secant squared, what function do you think you get?
Cosine squared.
Cosine squared. Okay, so I'm going to show you how one of those could come up. Let's do this one. Okay. Let's do 1 over secant squared plus 1 over cosecant squared. Right? And this time I'm not going to tell you what the answer is, I'm just going to say simplify. Okay, so simplify is a little bit harder because you don't know what you're supposed to end up with. Okay. Let's start with this one. What is 1 over secant squared?
Cosine squared.
That is cosine squared. So if you forget it, pretend like the 2's not there for a second. Think about, okay, what would happen if I just took secant and flipped it? I would get cosine. When you have secant squared and you flip it, it's cosine squared. How about this one? 1 over cosine squared.
Sine squared.
That's sine squared. And what's cosine squared plus sine squared? 1. And that is as simple as you can make it. So if you had to take and do this, the answer is always going to come out to 1. It's always 1. And there will be one. There'll be one like that on the test. But it's very, very similar to what I just did right there. Any question on that one? Okay. Why don't let me put one up and I'll give you guys a couple minutes to try it. Because I can just keep doing them all day. Right? You got to kind of try one and see if you can figure it out.
Is there anything else that we're doing today?
No. Okay, so this is a verify. It could use any of the identities we learned from Monday or the new ones that I showed you today. Okay, at this point, I've shown you every identity that you need to know. Okay, it's just a matter of figuring out how to use it in that problem. If you start doing this problem and you're getting to like your 3rd step, 4th step, 5th, 6th, you're getting into like 10 steps, you probably didn't do something right. Okay, if it starts taking that long to do, there's probably something you missed that would have been a lot easier. Okay, so this one says tangent plus cotangent over secant times cosecant equals 1. Okay, so the hint, you're always going to start with the same approach we use. Try changing things to sines and cosines. Once you do that, you can try finding common denominators if you need to. And as far as changing to sines and cosines, when I have a fraction, I wouldn't change this to sines and cosines yet. You might have to eventually, but I would just do the top as sines and cosines and just try working with the top for now. And then if you need to change the bottom later, you can. To me, it's just a little simpler if I don't try doing the top and the bottom of the fraction at the same time. So I would work with just the top. Right, and we'll take a look at that in a few minutes. So one thing that's going to be important that comes up in this one is basically this rule from arithmetic. If you have a number in the top and two numbers multiplied in the bottom, you can separate that into two separate fractions. Because think about if you multiplied straight across. You would do 1 times 1 in the top, and then you do 4 times 5 in the bottom. So this fraction is exactly the same as those two. That idea is important in this problem. That's not trig. That's just arithmetic. Okay? So now let's go through it and see what happens. Okay. So when I gave you a hint, I said for now, just leave the bottom as secant times cosecant. If you change it to sines and cosines, it's okay. You can still do it that way, but I think it's going to be more work. So let's just work with the top. Okay? So all I'm going to do is focus on what's in the top. I'm going to come back and look at the bottom when I'm at the end. Okay. What's in the top?
Tangent.
So it's tangent plus what?
Cotangent.
Cotangent. So we're going to do this as like its own problem. Tangent plus cotangent. What can you change tangent to?
Sine over cosine.
Is this something we should do, like when there's like problems that look like this, should we split it up like that and just do the top?
Well, yeah, the reason I'm looking at just the top is because I know that this divided by this is supposed to come out to 1. What's the only way that a fraction ever comes out to 1?
They both
They're the same.
both equal.
Right, the top and the bottom have to be exactly the same thing. So my goal is to somehow see, can I make the top secant times cosecant? If I can, then everything will cancel out and it'll become 1. So I'm just working with the top.
Okay.
All right, so I've got sine over cosine. What's cotangent?
Cosine over sine.
Cosine over sine. Okay, now the mistake that people made here, they went like this. Sine in the top, sine in the bottom, cosine in the top, cosine in the bottom.
We have to multiply.
Yeah, that's only for multiplication. This is addition. When you have addition with fractions, the only thing you can do, common denominator. Okay. What's our common denominator here?
Sine times cosine.
Right. The common denominator is always the product of the two, sine, cosine. What is the fraction on the left missing to make it the common denominator? It's missing a sign. And what's the fraction on the right missing?
Cosine.
It's missing a cosine. And remember, if something is missing and you multiply by it, you need to do it in the top and the bottom. Okay, so what's my common denominator now in both?
Sine and cosine.
Sine and cosine.
Times
Sine, cosine. You're going to have a plus right there. And what is this part?
Sine
Sine squared.
Sine squared.
And cosine.
And what about this part?
Cosine squared.
Cosine squared. What is sine squared plus cosine squared?
1.
1. So now you have 1 over sine times cosine, which is exactly the same as what I showed you right here. It's 1 over sine times 1 over cosine. Now remember, this is the top. What do you get when you flip sine?
Cosecant.
You get a cosecant. And what do you get when you flip the cosine? We already got a cosecant.
The cosine.
cosine.
When you flip the cosine.
Secant.
Secant. That's what the top is. It's cosecant
And
times
then wouldn't they
secant.
like cross out from the bottom too?
Okay, so yeah, now let's write down the whole thing. So now let's do the top over the bottom. So the top is cosecant, secant. And what was in the bottom?
Secant and cosecant.
Secant and
So
cosecant.
what if they
And there's no addition there. That's all multiplication.
So multiply.
So we can, yeah, we can cancel things out. What's the same in the top and the bottom?
Cosecant
Cosecant
and then secant
and secant. Everything canceled.
equals 1.
So all you're left with is a 1. And that's how you do that.
Maximum effort.
Okay.
Well, you definitely did your hardest on that one.
Any question on that? Alright, let's try one more. Let's try this one. Now, when you look at that one, which side looks more complicated, the left or the right?
Right.
Both? Yeah, they
No.
both have fractions, right? They both have a sign. One of them has a 1 plus, one of them has a 1 minus, and then the other part is just a cosine. So they're almost like mirror images of each other. They're kind of the same thing. So in this problem, when you simplify it, it doesn't actually simplify that much. Okay?
So fun.
It basically just changes place. So we can start with either the left or the right.
Left.
We're going to start with the left. So left-hand side. So we have 1 minus sine over cosine. Okay. What do we generally try to change all the trig functions to?
Sine and
We try to change them to sine and cosines.
That's
Okay.
already
Should we change everything to sine and cosines here?
No.
No, it's already there.
It already is, so we can't do that. Next thing we do is we try to make sure we have a common denominator. How many fractions do we have right here?
One.
1. If you only have one fraction, then you're not finding common denominators. You need 2 fractions. So there's only one thing left that we can do, and we haven't done it today, but we did it on Monday. And it has to do with this. Anybody remember something we can multiply by? It wasn't called the inverse. It began with a C. Multiply by the
conjugate.
the conjugate. Yep, that's the only thing left that I showed you on Monday that we can try. What's the conjugate of 1 minus sine?
You flip the box.
1 over 1 plus sine.
Not reciprocal. Reciprocal is when you flip. Conjugate is when you. It's simpler than flipping
The
it.
denominator.
1 plus sine. Okay. So the conjugate is when you just take this and make it the opposite of whatever it is. Right? Those are the 3 tricks we can always try. Change to sines and cosines, find a common denominator, but those don't apply in this problem yet. Or the third one is multiply by the conjugate. So those are the 3 things you always want to try. So let's do 1 plus sine over 1 plus sine. Okay, whenever you multiply by a conjugate, don't worry about doing the bottom out. Just write it exactly the way you see it. Cosine times 1 plus sine. The reason I'm not worried about distributing cosine to both of those is because something's going to cancel out. Okay, so anytime you multiply by the conjugate, never do this part out. Just leave it the way it is. Always do this part out. And we did one like this earlier today, where we had to FOIL, and something nice is going to happen. Okay. What's 1 times 1?
1.
1. And then what's 1 times sine? Sine. And now watch what happens here. What's 1 times negative sine? Negative sine. And what about a negative times a positive gives us
Negative.
a negative. And what's sine times sine?
Sine squared.
Sine squared. Okay. Does that look like what we were supposed to get right here?
No.
Not yet. Okay. But it's got some things that look like it, right? A little bit. What happens in the top?
The Signs cancel out.
Plus sign and minus sign.
We have 1 minus sine squared.
So we have 1 minus sine squared. Let's write that down. Keep the bottom the same. Okay. 1 minus sine squared. We've used every trick at this point. We've changed to sines and cosines, or we didn't need to. We already have a common denominator, because there's only one fraction. And we've already multiplied by the conjugate. Those are the only 3 things that you'll ever have to do. So the only thing left is something here must simplify, because it's one of the formulas I wrote down earlier. Anybody have a guess if it's going to be in the top or the bottom?
Top.
It's going to be in the top. 1 minus sine squared. Kind of like that, but a little different. Let's look at that formula.
When did he go cosine squared?
Okay. We have 1 minus sine squared. How would you put that sine squared on the other side?
Subtract the sine.
Subtract it. If you subtract it from the left, that's gone. Now you just put it on the right. What does it say 1 minus sine squared is?
Cosine squared.
Cosine squared.
1 minus sine squared turns into cosine squared. Yep. So now, okay. So what did we say 1 minus sine squared is?
Cosine squared.
Cosine squared. Over cosine 1 plus sine.
Cosine
What?
squared.
So what does the top and the bottom have in common?
Cosine.
It has cosine, so we can cancel that. How many cosines are in the top?
2.
2. How many are in the bottom?
1.
So it's
1.
cosine.
So how many can we cancel?
1.
1. 1 from the top, 1 from the bottom. Now you're left with what in the top?
Cosine
Cosine in the top,
over 1 plus sine.
over 1 plus sine in the bottom. And that's what they wanted you to get. Okay, so the trick here that sometimes people don't see was this, multiplying by the conjugate. And once you do that, a lot of things cancel out, and then you're at the second to last step. That's the whole problem. Okay,
And
any
you
question?
always multiply by the conjugate?
You always can, it won't always be useful.
Yeah.
Like if you had a problem like this one, I would definitely say do not multiply by the conjugate. Conjugate, you're usually looking for like a number plus or minus a trig function. So like those are conjugates. That's a good one for a conjugate. But yeah, this one that we did here, there's no conjugate in that first problem.
Yeah. Okay.
Like that one. Okay, any question on that last one?
No.
Okay. Let's try one from the homework. Alright. So this is an example. I'm just going to review a few different ones from yesterday and today. What should we try in this problem?
Make cosecant, cosine, or tangent, or sine.
What do you want to make it?
1 over sine.
Yeah, 1 over sine. And what about cosine?
Keep it as cosine over.
Let's just make it cosine over 1. And if you multiply straight across, what's in the top?
Cosine over
over sine.
Which equals cotangent.
Which equals cotangent. Now, that's a simplify, so you don't know what the answer is, but that is the answer. It's cotangent. So you'll have something like that on the test. Question on that?
No.
All right. Let's try this one. Let's try tangent times cotangent. Tangent times cotangent minus cosine squared. All right. What should we do in that one?
Well, tangent is sine over cosine.
tangent is sine over cosine. Yep.
Cotangent is sine over cosine. Cosine over sine.
Cosine over sine. And that's all I would do for now. I'd leave the cosine squared where it is.
And then those cancel out because it's multiplication.
Right, this is multiplication. So cosine in the top and bottom, this is what people wanted to do on the one we had today, but you couldn't. But here you can. So that's also gone. And what are you left with?
1
Minus
cosine,
cosine squared.
which equals sine squared.
Right, 1 minus cosine squared, we did that back here somewhere. 1 minus cosine, we did it a little different, but 1 minus cosine squared is equal to sine squared. Yep, and that's the answer. Okay. Any question on that?
No.
That's pretty similar. You'll see something like that on the test as well. Right, let's try this one. How about 1 over cosecant squared plus 1 over secant squared. So this one is a little different. It's one we talked about earlier, but it is another group of problems that I gave you
The
earlier.
x doesn't change anything.
No, it could be an x, it could be a theta.
Okay.
That doesn't change it.
1 over cosecant equals sine.
Yeah, if you flip cosecant, you get sine.
Sine squared.
So that, if you flip cosecant squared, you get sine squared.
Plus cosine squared.
And if you flip secant, you get cosine, but this is secant squared. So it's what?
Cosine squared.
Cosine squared. And what's sine squared plus cosine squared?
1.
1.
Wait,
So-
what's that one?
Because that's a formula I gave you at the beginning of the class. Sine squared plus cosine squared equals 1. Okay. Any question on that? Okay, I think that's that should be pretty good. Let me put up. So the homework, we're not going to do the worksheet because the worksheet, it's got some harder problems on it, and those aren't going to be what you're going to see on the test. So this is more like what's on the test. So it's 9 through 14, and actually, let's make that 9 through 9 through 13. I gotta fix 2 questions. So let's make that 9 through 12. Yeah, that's good. So 9 through 12 all, and then 29 through 27 odd.
What does omit mean?
Omit means to skip. So I want you to do 19 through 27 odd, but skip 21. Because 21, we have not talked about how to do it. Okay, so 9 through 12 all, and then 19 through 27 odd, but skip 21. Okay, so that finishes 3-3. That was the harder thing for the week. The last section we're going to do is area of triangle, and we will do that tomorrow.
I'm not gonna go on Friday, right?